Section 6.2 is going to be all about kites and trapezoids. On this example, on example 1, it did not give you a picture. We need a picture, okay? So we're going to draw our own kite and we're going to talk about it. Okay, so go ahead and draw yourself a kite in this area right here in your notes. Okay, so this is what a kite looks like. Okay, it's a four-sided shape. And then we have vertices A, B, C, and D. Okay. First thing I want to do before we look at the questions it's asking is I want to talk about different properties of a kite. Okay. A kite has two pairs of congruent sides. Okay. What side do you think looks congruent to AB?
BC.
BC. What do you think looks congruent to AD? DC. Okay. Those are our two pairs of congruent sides. Okay. Another thing we're going to talk about is diagonals. Okay, diagonals go through the shape. They go from vertice to opposite vertice. Okay, they cut across the shape. Okay, how many diagonals are there? There's two. Here's the other one. Okay, those diagonals are perpendicular bisectors. What does that mean? Makes a right angle. So right here, I'm going to call this point here X. Right here, that is a 90-degree angle. Okay, what's bisector mean? Splits it in half. What it does is it splits AC into two equal parts. Okay. Do you think it splits BD into two equal parts? It does not. Okay, it only splits the small diagonal in half. Okay, so this kite has two pairs of congruent sides. It has two diagonals that split the smaller one in half and create a 90-degree angle. Do you agree that these other three angles are also 90 degrees? Everyone agree? If this one's 90, are all the other ones 90 also? Yes, so keep that in mind. It isn't just one corner. It's the whole thing. All of those are 90 degrees. Okay? That's all you need to know about a kite. Let's go answer A, B, and C. It says, what is the measure of AXB? It will help if you start to draw these, okay? Or you're looking for different angles. So AXB is here. What's that angle measure? 90. Yep. So measure of angle AXB is 90. Letter B, it says if AX is 3.8, it wants to know what AC is. What's 3.8?
Like 7 point.
Right. If this is 3.8, what's this one? Also 3.8 because they're congruent to each other. Okay. So how do we find the whole thing? Add the two parts together. So 3.8 plus 3.8 is 7.6. Good. This last one, part C, it's asking you a question. It says if BD, which is this diagonal, if that diagonal is 10, does that mean that BX, this one on the inside, is 5? Why not? Because they're not split in half. It's not congruent, okay? So this is not true. It is not split in half. Okay? Another thing we need to talk about is when we have different angle measures in kites, okay? This one's not in your notes yet, so everyone look up here. I want to find measure of angle 1, 2, and 3. Okay, which one can we assume right away? 1. What is measure of angle 1? 90 because... Right, those diagonals, wherever they cross, as long as it's a triangle that has those two pairs of congruent sides, okay, wherever they cross, they create that 90-degree angle. Good. How can we find measure of angle 2? Where'd you get that from? Right. Remember all of these are what? 90 degrees. What you are going to want to notice often and see is that it creates triangles. Do we know pretty much everything about triangles? Yes, so we want to use those to our advantage. If I know two angles, how do I find the missing one? Yep, I add what I have. which is 90, plus 35, which equals 125. What do I do with that 125? 180 minus 125 gives you 55. So that is our measure of angle 2. What do we think about measure of angle 3? It is 35. Okay, you can assume symmetry here. Since this angle here is 35, this angle over here is also going to be 35. Okay, similar, since we said this angle 2 is 55, what do you think this one is? Also 55. Yep, so you can assume the symmetry there in the corresponding parts. Yeah? Go ahead and try example 2, A and B. Looking at this diagram here, what is one thing we can assume right away that's going to help us out? The 90 degree made by the two vertices, or the two diagonals. Yep. How does that help us find measure of angle 1? Right. This right here is also 90. Again, always see if you can find triangles. They make your life easier. Okay, so if I know 2, I can find the third. I take 32 plus 90, which is 122. What do I do with 122? Bingo. Yep. What's 180 minus 122? 58. So angle 1 is 58 degrees. Okay. What's measure of angle 2? Where'd you get that from? It's the same. Yep, you can call it corresponding. Good. Off in your margins of example 3, we are going to draw ourselves a picture so that you can reference back to it. Okay, so in this area, you're going to draw what I have up here. We're going to be talking about isosceles trapezoids. So go ahead and write isosceles trapezoids. Where have you heard the term isosceles before? Isosceles triangles. What does it mean to be an isosceles triangle? Two sides and two angles. Okay? Isosceles trapezoids pretty much follow that same thing. Okay? Go ahead and draw yourself a trapezoid. And just label it for now A, B, C, and D. Okay. Something to know about trapezoids, isosceles trapezoids, they have a pair of parallel lines. So what these are called, we're going to refer to them as bases. So I'm just going to label one base 1, label it base 2. Does not matter which one's base 1, which one's base 2. Okay, those are our two bases. So isosceles has what? Two sides are the same. Which two sides look the same? The sides, right? AC and BD. Those are our two congruent sides. What do you think our two congruent angles are? Yeah, I heard it. It's the bottom ones. Yep. C and D. What do you think about A and B? Do they look the same?
Yeah.
They are. Yep. So, isosceles trapezoids, their AC and BD are the same length, and their base angles, those base angle pairs are the same. Okay, so the top two angles on the base 1 are the same. The bottom two angles on base 2 are congruent to each other. Okay? So, keep that in mind. Let's look at number 3A. So, 3A here, it tells us it's an isosceles trapezoid. So, let's label this picture a little bit. What do we know about isosceles trapezoids? Two sides are the same? What else? Which ones? Right. Q is congruent to R. P is congruent to S. So, let's listen to our markings here. If R is 135, what's Q? Also 135. Cool. How do I find measure of angle P and measure of angle S? It is. I'm going to back us up just a little bit, though. How did we find missing angles and triangles? We added it up and subtracted from 180. What is the interior angle sum of a quadrilateral? It is 360. Okay, make that note real quick. This is 360 degrees on the inside. So, how would we find the other two missing angles that are the same? Yep. We would take 135 plus 135, which is 270. What do I do with 270? Yep, 360 minus 270 is 90. Right, because 90 is both of these. So now I take 90 divided by 2, which is 45. Okay. Is that very similar to what we did with isosceles triangles? It's the same exact process, okay? Just a different sum. What do you notice about, I want you to compare this angle compared to this angle. They equal 180. Yep. So, if I know one of those top angles, do I even need to go through all this work right here? No. Okay? You can understand the relationship that I know that these are going to add up to 180 degrees. Okay? For isosceles triangles. Go ahead and try part B. So, on this one, how do we know that it's an isosceles triangle? Sorry, trapezoid. How do we know that it's an isosceles trapezoid? The sides are congruent, okay, and what does it tell us in the directions? That they're parallel. Yep, so we know that this is an isosceles triangle. We can assume all those properties, okay? How does this 47 degrees help us if we want to find this angle here? Right here, they're on a straight line, so this one, we know they add up to 180, so we can take 180 minus 47 is 133, so that is this angle right here. So how do we find TUR? Why? Right, it's an isosceles trapezoid, so we know that these base angles are the same. So if R is 133, what's U? Also 133. Okay. If I wanted to find, just for fun, if I wanted to find measure of angle T, how would I find that? I'd take 180 minus that 133 to get back to 47. Good. In kites, what did we call lines that went from vertice to vertice? Diagonals. Yep. So in this diagram here, trapezoids also have diagonals. Okay, they go from opposite vertice to opposite vertice. A note I want you to write down next to example 4. Okay, diagonals in isosceles trapezoids. What do you think are? Yep, are congruent. What does it mean to be congruent? They're the same. Okay, so in isosceles trapezoids, diagonals are congruent to each other. They are equal to each other. Okay, so first thing in this diagram, how do I know that it's an isosceles trapezoid? Yep, parallel lines are the same, and we have the same side lengths. Okay, so we know that it's an isosceles trapezoid. What did we just learn about these diagonal lines? They're the same. Right, to find the value of C, we're going to set equal to each other. So 4C plus 3 equals 6C minus 5. How do I solve this? I heard this first. Yep, subtract 4C. So we have 3 equals 2C minus 5. Add 5. A equals 2C. What do we get for C? Yep. If I wanted to know the length of the diagonals, what do? Plug it in. Doesn't matter which one? Doesn't matter because they are what? They are the same. Yep. Go ahead and try example 4. All right. What do I have in this diagram? What are those lines called? Diagonals. What do I know about diagonals? They're congruent. So how do I set this up? Yep. A plus 13 equals 2A minus 1. What do? Minus A. So I have 13 equals A minus 1. Add 1. What do we get for the value of A? A equals 14. Good. Margins. we are going to talk about the mid-segment of trapezoids. Okay. Mid-segment of trapezoids, what that means is we are looking for the length of that midline through the center of the trapezoid. Okay. What I want you to understand about this midline is it is equidistant from both bases. Okay. It is equidistant from both bases. Okay. Here's a formula I'm going to give you that you may use, you may not. Okay. There's different ways you can solve this. I'm just going to supply you with a formula in case you want to use it. Okay. So mid-segment equals base 1 plus base 2 divided by 2. What mathematically is happening here? What's that called? It's the average. Yep, we're finding the average of the two bases. Okay? Remember, it does not matter which one is base 1, which one's base 2. Okay? Just as long as you have the bases, not the sides. Okay? It has to be those two parallel lines. Okay? So, I want to look at this example real quick. Finding the mid-segment, we are finding the length of this line down the middle. So, couple different ways you can do this. What's one? Use the formula. Use the formula. So, mid-segment equals what? What are my two bases? 6 and 9. Yep, so 6 plus 9 divided by 2. Yep. What's 6 plus 9? 15 divided by 2 is 7.5. 7.5. Okay. So, is 7.5 equidistant from 6 and 9? How far away is 7.5 from 6? 1.5. How far is it from 9? 1.5. Yep. Couple different ways you can do these and think about these. It's totally up to you. Okay, let's look at number 5 together. This is the last example we're going to do together today. Okay, what do you notice about this example? There's a fraction. What else? We're missing a base. That's actually what we're looking for. We're looking for this base. Could. Do we know what the other base is?
No.
Can we find the other base?
Probably, yeah.
How? Right. Do we know what this is? It's 25, right? So what if we plug 25 into there? So let's do 4/5 times 25. Remember, you can think of this as over 1. Okay, all I did was I plugged xy into xy. Okay, how many times does 5 go into 25? 5. 5 times 4? 20. What did that just give me? It gave me JM, this one. Yep, so JM is 20 meters. Couple different ways you can find KL. What's one? What'd you say? Yep, let's do it. Plug it back into the formula. So we know the mid-segment equals, what's the formula? Yep, base 1 plus base 2 divided by 2. So let's plug in the values that we know. What's the mid-segment? Mid-segment's 25. What are my bases? X and 20. Doesn't matter the order I put them in. No. Okay, and then we have divided by 2. Do we like fractions? No, get rid of them. How do I do it? Multiply by 2 on both sides. 2 times 25. 50 equals... Yep. And then how do I solve? Subtract 20. So we get x equals 30. What did that just give us? That gave us our other base. Is there a different way you could do that? Right. Remember, these are equidistant from each other. Okay, so how far away is 25 from 20? 5. So what should this distance be? 5. Okay, so you went from 20 to 25 to 30. You can do it either way. Do you get the same answer? Yes, you can do it either way. Okay.